Hello everyone, I am MyungJoo. I'm from Samsung Research. The title of my presentation is On-Device, Unlocking On-Device LLM, especially the devices that we can use for the household goods. On-Device LLM, well, not only theoretical research is being done, but also in your own goods and product, it's now being embedded. And in order to do that, Samsung Research has been doing a lot of research, and I'm sure they're utilizing on-device LLM, how you can actually utilize it. So I hope my presentation can be useful. Let me begin my presentation. So in order to realize on-device LLM, how we do that, what's the level of that, let me tell you, and also how we can actually apply that. Not only we stop there, but also there are many steps that we have to undergo. And internally, we provide diverse services. Last but not least, on-device LLM, how we can implement that, what kind of software we need. We provide software as well, and I'd like to introduce the software that we can use as well. What is on-device LLM? Well, inside the device, LLM is now being deployed. So inside the device, when the device is implemented, then we can use the data, private information, especially the data that cannot be released to outside. You can get service, and also using the resources inside the device, you can use that. So although the internet is not being connected, you can do that. So there's no delay or no lag time. You can get all kinds of services that you'd like to enjoy. Such a great LLM, when it's on device, where can we actually use that? What kind of service are we entitled to use? ChatGPT or other services, I'm sure that you use that a lot. And LLM is not built just for the ChatGPT, right? If it's just for the purpose of using ChatGPT, then definitely you can use that. But we didn't create on-device LLM for that purpose, but rather for server, there were things that we couldn't do so. But using on-device LLM, we can actually use all kind of services. For example, let me explain what kind of services people can use. You can see on the left, it's a now brief. So the users recommend the schedules, or there are services that users can use, and the sleep quality or the health based on the data. The device can provide services recommending certain behavior or certain things. Not only that, like a news article or telephone conversation, or if you attend a certain lecture, the contents can be summarized and then can be provided. And definitely interpretation and translation using on-device LLM, you can enjoy the service. The quality is far better than the existing one. And also the reply is really automatically produced with a high quality. From the simple model using on-device LLM, it understands the context and also even the patterns, speaking patterns, and the way the users respond, it can mimic that. So not only text-based service, but also the photos can be searched or documents can be identified. Anything that are inside the device, it can be used. Not only what I'm showing you now, but also there are other areas where it can be used. So not only the mobile phone devices, but in other product, the more LLM application is now being used. So on-device LLM, for that, Samsung Research is doing a lot of research, and let me introduce on a high level. Definitely, during the previous session, you heard about a small LLM model. Yes, we need to create that so that it can be embedded on device. And it doesn't mean that a small LLM can definitely create an application, because each application has its own task to carry out, and we need to modify or we need to orchestrate that. And definitely the app developer, they can easily acquire the usage that they would like to use. And based on that, depending on the usage, we can come up with the on-device LLM, but also we need a memory, latency, and throughput. In order to implement this in a software, of course, you had a big device, but in order to use this in on-device, you need lower memory, lower latency, and high throughput. To customize that as well, we are trying to develop a better on-device LLM. When you have such engine, the data needs to be input, and also we need to provide a foundation. So these are the framework. So if I compare that with the server, this is LLM to be implemented within the server. So Samsung Research is doing research on that so the LLM can be deployed. Among them, let me introduce the first thing. What we are trying to produce is on-device LLM, the small language model. Let me tell you what's the current level. So it's on device and the language model, starting with the Galaxy S24. With the name of the Galaxy, we are providing the service. And it's operated based on the small LLM compared with our competitor. You can see that Gauss on-device model, the parameter number is about 4 billion. It's less than 4 billion. It's around more than 3 billion. So I'm comparing that with our competitors, and their language model is much larger. So when we compare our small language model with the language model with more than 4 billion, the performance is actually better. And about 6.8 billion model, when we compare, the performance is not lagging behind at all. So with much smaller language model, but on par or better performance, we provide service at a much quicker pace. So on-device model, in order to compress it, the parameter numbers need to be maintained. However, the capacity needs to be compressed further down, or we call it as a quantizations. So one parameter has a capacity of about 4 bits, but now we are going further down and we are moving toward 2 bits. So we are doing research so that we can compress further down. In a very aggressive way, we are carrying out the quantization. In the future, we believe that the on-device LLM, the size will be by halves and then the performance will be double. And LLM, if that wasn't that burdensome, then we hope to realize far better performance with the same speed. That's our expectation. So such a great compressor, high speed, on-device LLM, even if we have that, what if we cannot embed that in our device? The post-process is extremely important. We need several steps. We call that as each developer to develop, not to develop their own model, but we provide one service. So the app developer, without having a full understanding of the model itself, they can provide the service. So the service is critical because on-device LLM, a small language model, has very unique features compared with the large language model. Especially the language model on device is compressed to 1/100th of the actual large language model, which means that the high speed or high performance cannot be on a par, which means that computing is quite challenging. However, as long as we give the right prompt, then the work can be done. But it's quite challenging, especially in order to ask the small-scale LLM to do a complex task. Sometimes the speed or other process cannot be well done. Another feature is that the memory is very small compared with the large language model. So the context, the length is very much limited. Under such circumstances, on-device LLM, in order to use that, we call fine-tuning or additional learning process. In order for the on-device LLM to do additional learning, we need to create a task data set and then let this small LLM to learn about that. But to do that, we need fine-tuning. For example, when we use LLM, there's application. If there are more than 20 applications on mobile phones, we need 20 variable or 20 different LLM. It doesn't mean that we cannot install 20 different LLM. So what we do is we just embed adapter, and using LoRa method, we do that. And creating LoRa, well, for the app developer, it's quite difficult to do so. So we provide it as a service. Through fine-tuning, when adapter is deployed, I'll share with you one example how effective it is. Samsung Health message, when it's being produced, the prompt is well done. So in a short summary, important message is given to users, but small language model, when instruction is given, you can see that it's in English. Even though we ask the applications to send the message in Korean, it is written in English. So the instructions we give needs to be complied with. In a simple manner, we hope to generate the message in a short format. Not only that, there are many other work or tasks that can be done on device. So app developer needs to do that. And as a one service, we provide that. Here, prompt engineering is included. Prompt engineering looks like very simple things to do so, but unless you have used LLM for a long time in an expert way, it would be quite challenging to utilize prompt engineering. So a semi or quite a bit of the automizations can be possible, and also each engineers need to create its own data sets, and it's very expensive to create data set one by one. So small data sets needs to be augmented to a large data set. We provide such a service. Definitely, as I briefly mentioned, the fine-tuning, additional learning can be done, and quantizations, yes, it's quite challenging work. And starting from the prompt engineering all the way to the quantizations in a one pipeline, all the services provided automatically. And using the models and devices, it's being distributed. The test and evaluation is done as a service. So under the name of the AI Studio, using web server, we provide to the outsider. Unfortunately, this is not provided to outsider, but inside the Samsung Group, we provide this service. So using this, even though the software developer, you don't have the LLM understanding, you can easily and quickly create this and then use it. Last but not least, when LLM is created, when the adapter is created, how can we adapt that to our household goods, including mobile devices or fridge or anything? What kind of software we provide? Let me share that with you. Starting from here, it's an open source, which means that you can use this even though you are not a member of the Samsung Group. The first software is NN Trainer. It's Apache license, open source, and not only Samsung Research, but developer outside Samsung are currently developing this. And then Trainer software is using the data inside the device, and then the software teaches learning large language model to learn. So robot cleaning devices or air conditioners, they ask the AI to learn additional information so that they can provide more suitable services to the users. So compared to the server, a very small or minute software can be installed, and using that features, we are installing on-device LLM with a much smaller software. And definitely because of that, the LLM can be operated in a much faster way. Here I'm showing you a demonstration video, and Galaxy 25 3 billion parameter, yes, is now being used. As you can see in this video, 3 billion model, but still at a mobile phone the result is quite fast, and the memory is not that huge in your mobile phone, but still you can see that if you look at the memory usage, it's merely 1.3 gigabytes, and the model size is about 16.5 gigabits. And as you can see, about 10 tokens per 10 seconds, that's the performance, is now being shown. And in this image, NPU and GPU is not being used, only CPU is being used. Still, the performance can be used. And well, even if you can use the total of the 16 gigabytes with the same computer when there's a limitation, then the speed is not that different. About 15 to 13, there's a mere differences. And the speed of the writing the sentences, there's minor differences, but from the beginning to the end, it's actually much more efficient. The reason why this is possible is because all the context is not written there, but it tries to identify what is really necessary. The model software understands that, so it does scheduling and then it upload what's important. It's not necessary, then it get rid of that. So in a very extreme manner, in a very fast manner, it does that. What you are looking at right now is for the laptop. So LLM on laptop CPU, it uses other framework. The speed is like double faster. Going back to the original purpose, LLM is more fine-tuned for the user's perspective. You can use it with the personal data, and even though it's the same task, so it's 6 stack, 8 multi-headed encoder, and then trainer use 420 MIB. So additional learning is possible. Another project I'd like to share with you is it doesn't do the LLM, but rather inside the device, it's a software that replaces, and TV or other household goods uses this software. Companies outside Samsung are co-developing this. They use this software for their products and services as well. And then Streamer, as you can see here, is currently providing services for 8 gigabits and API and data for LLM and the model for LLM are all distributed and being used. Let me tell you the takeaway of my presentation. It's written in one page. Samsung research for LLM. We are developing model about 3 billion parameter model, but also at a different purpose, different sizes. We are doing a lot of research for the LLM, and so that it can be applied. In order for these LLM to be used for a product, even though you don't have understanding about LLM, we are trying to provide services with the software that you can use it. And each devices, in order for this software to be implemented, we are providing the service in an open sourcing way. And there are other software that we have not disclosed yet, but we plan to provide at an open source. So you can take this open source software, or you can take part in developing it. Especially in November, Linux Foundation will be hosting open source summit, and NN Trainer, NN Streamer, and other AI software will be presented. There will be a workshop. Please join the Linux seminar and then share the information with us. That concludes my presentation. Thank you.